This naturalrefrigerants.com article is being read by an automated voice. Part 2. BACs. Heat rejection and single-phase immersion technology provide end-to-end cooling solution for data centers by Christina Hayes. Published February 18, 2026. This is an excerpt from an article featured in Atmosphere's Clean Cooling for Data Centers 2025 report, which can be downloaded here. Atmosphere is the publisher of naturalrefrigerants.com. BAC's COBALT immersion cooling system can be found in action at Skybox Houston One, an HPC data center in Houston, Texas, with 4 megawatts of installed IT power capacity. Operational since 2019, the facility runs entirely on renewable energy and operates in 100% free cooling mode year-round despite the notoriously hot and humid climate. The system features more than 326 U-wide immersion tanks, each housing 13 high-density servers submerged in dielectric fluid. These tanks are connected to a closed-loop cooling water circuit served by 6 BAC evaporative cooling towers for heat rejection and 5 pump sets that circulate water between the tanks and towers. Within the data hall, 4 computer room air conditioning (CRAC) units provide limited, non-mission critical comfort cooling. The use of BAC's immersion cooling technology substantially reduces the data center's energy use compared to a setup using CRAHs, computer room air handlers, which supply cool air to the server room via air-cooled chillers, according to Jan Thijsbert, Global General Manager for Data Center Cooling at BAC. IT power consumption was reduced by 20% as server fans were no longer required. Combined with the use of free evaporative cooling rather than mechanical cooling, and a streamlined system architecture, total energy savings reached around 80% for the cooling system and approximately 30% at the overall facility level. PUE versus TUE. While most facilities report power usage effectiveness, PUE, as their primary efficiency metric, BAC also highlights total power usage effectiveness, TUE, which is defined as the ratio of total facility load to compute load. PUE looks at the facility, but it does not look at the efficiency of the IT hardware, Thijsbert noted. It does not do justice to liquid-cooled facilities. PUE does not account for the effect of lowering IT load, such as by eliminating the need for server fans, and can therefore make a more efficient data center appear to have a higher PUE. For Skybox Houston One, the immersion and evaporative cooling configuration achieves a TUE of approximately 1.15 compared to 1.60 for a setup using air-cooled chillers and CRAHs. Beyond efficiency, the approach adopted at Skybox Houston One is extremely simple in design, resulting in low upfront costs and enabling easy scaling, Thijsbert said. It can work with any type of server and at higher process fluid temperatures, he noted. By integrating the immersion tanks directly with the facility's evaporative cooling system, BAC's design also reduces the data hall footprint, enabling operators to maximize compute density within the same physical space. It's actually unbelievable that we're not doing this for all other data centers worldwide already, Thijsbert said.